Equinox Observations, Flat Earth and Globe Earth, Part 5, Hours of Sunshine. This is the 5th video of our 6-video series, and all we need is the time of sunrise and sunset. So in preparation, you'll need the time of sunrise and sunset on the equinox. Either measure it yourself or document it. Also, we'll have a little bit of background about how sunrise and sunset are actually measured. So how do you get the time of sunrise and sunset? There's several sources of information. One of them is by personal observations. This is the preferred method, but you do need a clear horizon, like over water. Or you can get it from the local weather forecast, or you can get it from a website, such as suncalc.org. Here's an example of a local website showing the weather page, and it shows sunrise and sunset right there. Now this was not from the equinox, this is just a sample page. So how is sunrise and sunset recorded? What is the time? And the time is when the sun is appearing. So in other words, they didn't take the sun and treat it like a dot. They treated it like something that produces light over its whole surface. So this is a little bit unfair. In other words, this is biased towards more sunshine rather than less. So this doesn't really give us an even split. So another problem is refraction. So what we're going to do is we're just going to subtract 10 minutes from our total time that the sun is visible. So making careful calculations. Here we're going to do a little bit of arithmetic with hours and minutes. So just be careful with your numbers. So here's an example pair of sunrise and sunset times from 6:41 a.m. to 6:52 p.m. And what we're going to do is we're going to separate this out into minutes, which is a fraction of an hour, and then the large block of hours in the middle, and then the minutes, this is a fraction of an hour at the end. And then we'll try to combine all three of these. So the first time, sunrise, is 19 minutes before 7 a.m. Then we can take a block of hours from 7 a.m. to 6 p.m. That turns out to be 11 hours. And then lastly, we have the 52 minutes that's after 6 p.m. So again, we have minutes that's a fraction of an hour, a block of hours, and then minutes that are a fraction of an hour. And then we're going to total them up. This gives us 11 hours and 71 minutes, which we don't really call it that. We rename one of those 60-minute blocks to be an hour. So we have 12 hours, 11 minutes. Now remember, because of the unfairness of how the sunrise and sunset is calculated, we're going to subtract 10 minutes. So that gives us 12 hours and 1 minute, or it's pretty close to 12 hours. So, globe or flat? Now there are several possible scenarios and how we're going to analyze the data, so just try to keep an open mind, look at all possibilities. So on the equinox, in the globe Earth model, there is effectively no tilt to the Earth's axis. So half of the Earth gets sun from pole to pole. Whereas on the flat Earth map, the sun is simply following a circuit over the equator. So if you recorded between 6 and 11 hours of sunshine on the equinox, this might support the flat Earth model. So for example, here's an AE projection. The sun is over the equator. The sunshine is going from the North Pole to the ice wall. And I've drawn an illumination of sun that is equal, because a lot of folks say that the sun's light can only travel so far. So I give it an equal radius. And so the sun travels around over the equinox, or over the equator. Now, if you take a look at different latitudes, for example, Southern Europe, North America, there's going to be 10 hours of sunshine and 14 hours of no sun being visible. If you go down to the equator, there's 8 hours of sunshine and then 16 hours where there's no sun visible. And if you go even further south, such as Tasmania or the southern tip of South America, you have 6 hours of sunshine and 18 hours of no sunshine. So if you recorded 12 hours of sunshine, well, if you want to stick with the flat Earth map, you're going to have to change the pattern of illumination. So again, the sun must be above the equator, and the illumination cannot cross the North Pole. But the sun does go from the North Pole to the ice wall. However, we need to give all areas 12 hours of sunshine to match our observation. And so the pattern of sunshine might look something like that. So we have a little bit of a problem that's introduced here. The black arrow, which is from the sun to just over the North Pole, say the northern reaches of Canada in this illustration, they cannot actually see the sun. Whereas the yellow region goes to the ice wall, the most farthest southern region, they can see the sun. Because remember, if it's going to be 12 hours of night and 12 hours of day, or 12 hours of sun and 12 hours of no sun, we have to have a different illumination pattern. So if that illumination pattern doesn't make sense, maybe there has to be another flat Earth map. But this flat Earth map must account for equal day and equal night. When I say equal night, sun versus no sun. Because as you recall, equinox means equal night in Latin. The alternative is that the globe Earth model works. So in the globe Earth model, no matter what day of the year, the sun's rays are always going to illuminate 50%. The sun rays are going to touch 50% of the globe. On the equinox, this pattern of light and shadow is going to intersect the poles. So that model might work. So how many hours of sunshine did you record? Please feel free to share your results at flatearthmath.boards.net, set up by Cara Diane. And you can share your results there. Again, the message boards are not a place to do any debating. They're just for sharing your results. In our next video, we're going to cover Wagon-Wheel Sunspots. What you'll need is a pretty good quality zoom camera, a solar filter, tripod, but this is only going to work in a time where we have active sunspots on the sun, visible sunspots, because then we're going to see the wagon wheel motion of them across the sun. So please remember to be kind whenever possible, because, as you know, it is always possible. Thank you.